Hello, welcome to a review video. In this video, I'm going to go over the solutions to Quiz A from Chapter 17. All right, so here we go. First problem is this. The American Red Cross says that about 11% of the U.S. population has type B blood. A blood drive is being held at your school. Okay, so how many blood donors should the American Red Cross expect to collect from until it gets a donor of type B blood? Right, so this is a geometric problem. So remember I said first thing to do is kind of identify which model we should use. Geometric because we're waiting until we get a donor with type B blood. Okay, now it wants to know how long we can expect. So it's asking for expected value. So for the geometric model, expected value is 1 over P, the probability of success. So it'd be 1 over the probability of getting a person of type B blood. So it's 1 over 0.11, which is 9.1. So if you put that for the answer, you did really well. Okay, number 2. What is the probability that the 10th blood donor is the first donor with type B blood? That means we're waiting, and finally the 10th person is the first person we get for success. So again, this is a geometric model, waiting for success. Okay, and this is for a specific one, for the 10th donor. Okay, well, we can use GeoMet PDF. And in this case, P equals 0.11. The value we're interested in is X equals 2. And if you do this, you get 3.85%. This has a little review. We could actually figure this out on our own. We have to fail 9 times. The probability of failure is 0.89. And we have to get 9 people who are not type B. And then we're interested in our 10th person, which has probably 0.11 being type B. So this is how we could kind of do it by hand. But we have our calculator. All right, so we can use our calculator. All right, here are the next 2 questions. It says, what is the probability that exactly 2 of the first 20 donors have type B blood? Okay, since we're talking about only 20 donors, this is a binomial model. Okay, the fixed number of trials. And the number of trials, which is n, is 20. Okay, so it says, what's the probability that exactly 2 of the first 20 have type B blood? Well, we can use binom PDF. The number of trials is 20. Probability of success, 0.11. And the value we're interested in is 2. So if you enter that in your calculator, you should get 28.2%. That's what I got. Okay, just to be fancy, we can calculate this by hand if we really wanted to. So we got to multiply the number of different ways we can pick 2 people to be type B blood. So which 2 of the 20 are type B? Well, there's 20, choose 2 ways of doing that. Times, well, we have 18 people who are not type B and 2 people who are. Okay, so that's kind of cool. If you want to show off, you can do this by hand, but it should give you the exact same thing we got on our calculator using binom PDF. All right, number 4 is a little tricky. What is the probability that at least 2 of the first 10 blood donors has type B blood? So n is changed to 10 in this problem, and it's still binomial. Okay, well, we want the probability at least 2 means x is greater than or equal to 2. Remember, our calculator doesn't do that. It can handle equal or less than or equals. So let's consider the complement. Strictly speaking, the complement of greater than or equal to 2 is less than 2. But we're still out of luck because our calculator doesn't do that. So what I suggested in class is that in this case, this is actually equal to the probability x is less than or equal to 1. Let me take a second to explain that. X could take on as a number of successes. So out of 10 trials, x could be 0, 1, 2, 3, 4, 5, 6, all the way up to 10. At least 2 would be these cases I'm circling, right? It'd be 2 up through 10. What that leaves out is 0 and 1. That's the complement. So yes, we can write it either way in this case. X less than 2, x less than or equal to 1. Since we're only dealing with whole numbers, these two things are equivalent. A little bit tricky, but we got it. Now, this one is one my calculator can do. So to find this value, we can use binom CDF. The trials is 10. The probability of success is 0.11, and we're interested in x equals 1. All right, when I did that, hopefully everything went okay. I got 0.6972. And when we subtract that from 1, we get 0.3028, which of course is 30.28%. All right, so just a little bit of subtlety here. That's kind of subtle. All right, I think on the quiz, there's one in the stretch that's kind of like that. In the focus, we don't ask that. It's kind of like the other ones we've done. All right, let's move on to the last two. It says the blood drive has a total of 150 donors. Okay, we've changed, it's still a binomial model, but we've changed the number of trials again. Now it's 150. Assuming this is a typical number of donors for a school blood drive, what would be the mean and standard deviation of the number of donors who have type B blood? Okay, so it's just asking expected value and standard deviation. For the binomial model, that's a B there, expected value is N times P. Okay, so it'd be 150 times 0.11, and I end up getting 16.5. So if 150 students, on average, we expect to get 16.5 with type B. All right, the standard deviation, just using the formula, is the square root of NPQ, which is the square root of 150 times 0.11 times 0.89, which I got to be 3.83. Okay, all right. Now, last question. Surprised by the low numbers of type B donors at the blood drive, the American Cross wonders if 11% estimate was too high for your area. How many type B blood donors would it take to convince you that this estimate might be too high? Justify your answer. So surprised by the low number. So how low would it have to be in order for us to change our mind that it's 11%? Okay, well, we would think if it's 2 standard deviations below the mean. So we're talking about how low it would have to be shocking. 2 standard deviations below the mean. Okay, so the mean was 16.5. If we subtract 2 standard deviations, we get a value of 8.84. So I'm going to say 8 type Bs. I'm rounding down because this would make it less than 2 standard deviations. So if we got 8 type Bs one day, that would be unusually low. Or anything less than that. That might change our mind that, you know what, our 11% is really too much. It's really got to be lower. Because if it were 11%, this would be a little unlikely. Okay, so if you get a question like this and it's asking what would be unusual, an unusually high value would be 2 standard deviations above the mean. An unusually low value would be more than 2 standard deviations below the mean. Okay, well, that was our second round of problems like that. The review sheet had similar problems. This is our second time around with those, so think about those a little bit. And good luck on the test tomorrow. We'll see you later.